Humans are dreamers. We've always looked up at the stars and wondered, what's next? And no world has captured our imagination quite like Mars. Cold, red, distant. And maybe, just maybe, a blank canvas for humanity's survival. But what if that dream is actually a nightmare? What if our attempt to terraform Mars, to turn it into a second Earth, ends up backfiring catastrophically? This is the story of how we could terraform Mars and why it might kill us. Out of all the planets in our solar system, Mars is the most Earth-like, at least in structure. It has a day that's just 40 minutes longer than ours. It experiences seasons, has polar ice caps, and shows ancient signs of liquid water. Its surface temperature is freezing, yes, but not insanely so, and unlike Venus, it isn't crushed under a super-thick atmosphere of toxic gas. In the cosmic game of planetary real estate, Mars is the fixer-upper with potential. And that potential is what draws scientists, engineers, and billionaires into dreaming about making it our second home. The concept is called terraforming, the process of reshaping a planet's environment to make it more Earth-like. To terraform Mars, we'd need to do three big things: raise the temperature, thicken the atmosphere, and provide breathable air. None of that is remotely easy, but some scientists believe that with enough time, energy, and technology we could pull it off. The leading ideas range from unleashing greenhouse gases to importing ammonia-rich asteroids, or building giant orbital mirrors to heat the surface. Some even suggest nuking the poles to release trapped CO2. The goal is to kickstart a runaway greenhouse effect, just like Earth's ancient past, but on Mars. With a thicker atmosphere, Mars would begin to retain heat. The pressure would rise. Liquid water might stay on the surface again. And over decades or centuries, the red planet could turn into something green and blue. We could plant life, build ecosystems, walk outside without a pressure suit. That's the dream. But the universe doesn't care about our dreams. It cares about physics, chemistry, and chaos. And messing with an entire planet's climate. That's chaos on a planetary scale. Terraforming Mars sounds like science fiction, but the science behind it is rooted in real physics. The planet already has CO2 locked in its polar ice caps and soil. If we could release that gas by vaporizing the poles with nuclear detonations or using massive orbital mirrors to reflect sunlight, we could begin to warm the planet. As temperatures rise, more carbon dioxide would be released, creating a feedback loop. That thickening atmosphere would trap heat, and over time, Mars could inch closer to Earth-like conditions. It wouldn't be fast. Even with aggressive tactics, we're talking decades just to raise the temperature a few degrees, and centuries before any kind of breathable air exists. And speaking of breathable air, that's a massive hurdle. Mars has almost no oxygen. Even if we managed to warm the planet and thicken the atmosphere, it would still be completely unbreathable to humans. So how do we fix that? One idea is to engineer photosynthetic microbes, extremophiles that thrive in harsh conditions. These microscopic organisms would be released across the planet to slowly convert carbon dioxide into oxygen, much like Earth's earliest life forms did billions of years ago. Another idea is to introduce genetically engineered algae, or lichens, designed to survive in low-pressure environments. Over centuries, they could help shift the atmospheric composition. Meanwhile, we'd be building domed cities to shelter early settlers, controlled environments where humans could live while the planet transformed around them. These would function like small-scale Earths, with oxygenated air, pressure control, and water recycling systems. Outside the domes, robots and drones would maintain the terraforming infrastructure: heat mirrors, chemical reactors, oxygen farms, and more. Eventually, if everything goes right, the atmosphere might become thick enough to eliminate the need for pressure suits. Helmets, maybe. But not full-body life support. That's the best-case scenario, the dream. But here's where things take a dark turn. Because even if we succeed in warming Mars and giving it an atmosphere, there are consequences we might not be ready for. Every action in this delicate chain of events could spiral into unintended disaster. And nature, especially alien nature, doesn't give second chances. One of the biggest risks is atmospheric instability. Unlike Earth, Mars doesn't have a global magnetic field. That means any atmosphere we create is vulnerable to being stripped away by solar wind, just like what likely happened to Mars billions of years ago. On Earth, the magnetosphere protects us by deflecting charged particles from the Sun. Mars has no such shield. So even if we spend centuries building an atmosphere, it could start leaking into space the moment we stop maintaining it, unless we invent artificial magnetic fields or shield generators on a planetary scale. Our work could vanish in a cosmic blink. And then there's the issue of surface chemistry. Mars is covered in perchlorate, toxic salts that are deadly to humans and most Earth life. They exist in the soil, and disturbing that soil during farming, construction, or exploration could release hazardous levels of contamination. Imagine trying to grow crops, only to realize the ground itself is poisonous, and cleaning it up. That's a challenge we've never faced before, especially not on an alien world. But the most terrifying possibility of all: biological backfire. Introducing Earth life to Mars isn't just risky, it's irreversible. If we seed the planet with bacteria or algae and something mutates in the harsh Martian environment, we could create alien life forms beyond our control. Life that doesn't play by Earth's rules. Terraforming could become uncontrolled bioforming, a runaway process where engineered organisms don't stop at making the planet habitable. They change it into something else entirely, and once it starts, there's no way to hit undo. Plus, we don't even know for sure if Mars is sterile. There may already be microbial life deep underground or hidden in polar ice. If that's true, our actions could lead to extinction, not ours, but theirs. Terraforming Mars might be humanity's first act of interplanetary colonization, and its first act of interplanetary destruction. Even if we somehow avoid all those risks, strip loss, toxic soil, runaway biology, there's one more hurdle that's harder to measure: ourselves. Terraforming Mars would take centuries, possibly thousands of years. The people who begin the project will be long dead before it finishes. It requires patience, global cooperation, and long-term vision, traits that humanity doesn't exactly have a great track record with. Are we really capable of reshaping an entire planet for the benefit of people we'll never meet? And what happens to us, psychologically and culturally, if we succeed? If we can re-engineer a planet to our liking, do we become creators, colonizers, gods? Will we treat Mars with respect, or just as a backup Earth to exploit, mine, and pollute like the first one? The ethics of terraforming are murky. Are we saving humanity, or playing with power we don't fully understand? Some scientists argue that terraforming is unethical by nature, that Mars should be studied, not changed, that we have no right to alter another world. Others say it's our destiny, that if life can expand into the universe, it should, that Mars isn't a world we're destroying, but one we're awakening. In the end, the dream of terraforming Mars is a mirror. It reflects not just our technological hopes, but our flaws, our fears, and our values. It's not just a scientific question, it's a philosophical one. Can we transform another world without destroying what makes us human in the process? Terraforming Mars is possible, maybe even inevitable, but whether it saves us or destroys us depends not just on what we build, but who we become. Thanks for watching. If you enjoyed this video, hit that like button, subscribe for more science stories, and let me know in the comments what topic you want to see next. Until next time, stay curious.